Hey, this is Mr. Kabilski. I'm going to be going over some information so you can earn full credit on the 310 lab. Currently, you did not complete all the work as required, so first of all, I'm going to go over the lab part, and then we can look at any of the other data parts. So bear with me. I have two screens set up, so we'll go through cubes at the same time. So here we have the first small cube, and I'm going to put it on for 5 minutes there, and then I have the second. This is a oops, wrong one. Start there. So you can see here on the with the pink gloves on the left is the 1 centimeter cube. On the right with the blue gloves is the 2 centimeter cube, and we're doing them both for 5 minutes. So we're going to go ahead and do that and see what happens. And again, this is kind of time lapse, so I'm going through this pretty quick. Okay, I'm back. Now you can see after 5 minutes that this is what you're getting over here on the left side with the small 1 centimeter cube, and the 2 centimeter cubes on the right is changing effect as well. They obviously look considerably different. So let's go over here on this one, and we're going to stop the auger mix. We're going to reset it. We're going to take that out. Okay, and these are all things that you should have done. I'm going to cut that. Okay, and we're going to use the napkin to dab it. Okay, once you dab it, you can see the circle come up that says it's done. Okay, same thing on this side. We're going to stop it, reset, take that out with the blue gloves. Put that down. I can find a place to put it down right there. Cut it. Put that down. Go ahead and dab it. I think I need to move that over. There we go. Dab it. Put that down. And then we will start again. So we have the small block, the medium block, and I am going to do the large block, but this time I'm going to do it for 10 minutes. We're going to start it, and then we will come back. Notice how the edges are smooth. You can't really see anything except the definition, and we'll see how that changes as we go through this, so bear with me. Okay, the next thing we're going to want to do, and let's see, this is going to be interesting because I have a, hold on, I got to slide down, I got to slide over. So I got a couple things to do. So I'm going to make this bigger so you guys can see it better. And I'm going to attempt to go over and find, there it is. Okay, a little bit too much because I got to go back down. Okay, so what you want to do is you want to line up where it says CM on the left-hand side with the edge of the block. Now that edge of the block is right there. And you're going to approximate where you think that red starts. So the clear area is what you're trying to measure. That is, again, if you've read it, that's where the phenolphthalein solution has reacted with the vinegar, and the vinegar has diffused into the block. And I'm just going to go ahead and say that that is at 3 millimeters, 0.3 centimeters. Okay, so this one is 0.3 centimeters. And so let me go ahead and move this down and put it down if I can. Okay, and then I'm going to go over here to this side, and I'm going to try and do the same thing. Okay, so I'm going to make that larger. I'm going to grab it and hopefully be able to slide it over a little bit. Oops, a little bit too much, unfortunately. There we go. And I'm going to measure that, and it's going to look about the same where that block. Now, obviously, the red is smaller, the edge is less defined, so it's going to be harder to see. So that's what we're doing right there. I'm going to say that's about 0.3 centimeters or 3 millimeters. Let me go and put that down. Check of our block, you can see how the edge is of the block are starting to become clearer. So the vinegar that's stirring in this container on all 6 sides, okay, if it was flat on the bottom side wouldn't get the vinegar touching it, or at least not very well. So it has to be mixing. That's why the mixing action is very important. So we're going to come back and see how the diffusion happens there. So again, very clear. We did the first one for 5 minutes. So we did the 1 centimeter diffused, and they're using millimeters up here for the final rate. So we're going to use millimeters. So we're going to say 3 millimeters. We're going to say 3 millimeters for this one as well. Okay. And that's going to give us information. Now, the diffusion rate, it's like miles per hour. So how fast is it going at any given point? So we had 3 millimeters divided by how long? 5 minutes gives us a ratio. So if you go 3 millimeters divided by 5 minutes, it gives you 0.6 millimeters per minute. And that's going to be our rate. So we can copy that, do the same for here. And let's go back and see what our other one is doing. Is this it? Yep. So we're halfway there. Okay, let me go hide that. And away we go. Now again, you should have looked at this information. This is the surface area and volume ratio, and they give us examples. How many sides of a block? There's 6. The block is an example. This is our example. Is a length of 4, width by 4. So you do 6 sides by 4 by 4 equals 96. That's the surface area. Volume is length times width times height. So 4 times 4 times 4 is 64. Then you get a surface area to volume ratio. So you take the surface area 96, which we calculated up here. The volume 64 we calculated over here, and divide the two. So we get a surface area to volume of 1.5. So the same thing here. Sides, there are 6 sides. The first block has a length of 1, width of 1. So 6 times 1 times 1, and the answer is 6. Okay, the length of 1, width of 1, height of 1, 1 times 1 times 1 equals 1. Surface area 6, volume 1. 6 times 1 equals 6. And it's just that easy to calculate. Let's do the next one. Sides 6, length 2. This is the second cube, which is a 2 centimeter cube. Width 2, so it's 6 times 2 times 2 equals what? 24. Length for the volume, 2 times 2 times 2. 2 times, oops, 1 second, there, times 2 equals what? What's that going to be? 2 times 2 times 2. It's going to be 8. And then the surface area 24, volume of 8, gives us 24 divided by 8 equals what? 24 divided by 8 is 3. And that's basically how you get the surface area to volume ratios. And I'm going to leave the last calculation, which is this cube 3, to you. So let's look at where our block is currently. Okay, now you can again start to see how the edges are taking shape here. Now one of the things, if you noticed, let's go back to here, that our blocks, if you can see them, they're very similar in how much that they have diffused in. They have diffused in what? What's their rate that they diffused in? Well, both of them have diffused in the same rate. And that is what we're actually going to predict, and that's what you would get if you would run it with the larger block. And therefore that distance would be the same, the rate would be the same. Okay? The analogy here is that the diffusion rate, no matter what size of block, it's traveling at the same rate. Okay? It's traveling 0.6 millimeters per minute. Okay? So if this rate is the same, what do you think might happen over on this side? Well, if it's for 5 minutes over here and it's 10 minutes, it's doubling. So we could project, and again, I've gone through the lab, this is what I'm trying to help you with, that that rate would be doubled. So it would be 6 millimeters for each of these 10-minute times. Now, does anybody see a problem with this first? Well, let's do the calculation, so I'll show you. It's going to be the same calculation over here, except again, it's going to be doubled. So it's going to be 6 millimeters for 10 minutes. And interesting enough, it gives you the same 0.6 millimeters per minute. And we're going to copy that down here, and there's your chart. Now we have a little time in here, so let's go back to the other slide, the other one. This was a small block. Now, what are we measuring? We're measuring from the edge into where? Actually, towards the center, because remember, a block has 6 sides, so you're measuring from the edge all the way to the center. Okay, if the diffusion gets to the center of this block, what would happen to that red area, that phenolphthalein? Well, it would disappear because it's coming in from all sides. So if it's a 10 millimeter block, 1 centimeter, what's the farthest distance it can diffuse into the block? Half the block, which would be 5 millimeters or a half a centimeter. So if we go back to our lesson, is it this one? Nope. It is this one? Yeah, there it is. This actually can't happen. It can only diffuse in because at that point, it's going to be clear. So we're not going to actually know. It's going to end up being a clear block at that point. So we're going to actually change that value right there. And what we're going to do is we're going to say, well, we really don't know, okay, because it changed. Now we know that the block completely diffused in, so we know what happened, but we don't know the rate at which it happened, so we're not going to say what rate it is. We're going to say what happened. Distance diffused, it diffused the complete block or halfway through. So let's go back to our other lab, which was this one. Okay, we're just about done. Now this is 10 minutes. Now what did we project? We projected that our rate should be about 6 millimeters. Let's see what we get. And we're going to stop it. We're going to reset it. We're going to take it out. We're going to put it over here. We're going to dab it. You can see after you've done this a little while, you can get pretty quick on it. So you're going to dab it. And then we're going to go measure. So let's go this way. And actually, I'm going to see if there's any way I can move it. Yeah, I can move it down here. Whoops, I don't want that one. I want to move it down a little bit farther here. So I'm actually closer to my scale. So when I go over here, okay, let's look at this one. We're going to line it right up with this edge. Okay, and it's interesting. It's not quite. It looks like it's about 5 centimeters. I'm sorry, 5 millimeters or half a centimeter. So our rates are a little bit different, but that's going to be basically just a rounding value. So we're actually going to modify, because this was a little bit different than what we projected. And we're going to say it is what it is. So it went half the distance. So we're going to indicate, rather than what we're projecting, again, because this is an accelerated lab, but you can see that this side over here is what we call a linear value. A linear because what means it's a straight line. Okay, as you project, it's going to keep continuing if you follow this trend at 0.6 millimeters, no matter what the size of the block. Okay, over on this side, we're going to project that it's going to continue in a linear fashion, that it would be 0.5 millimeters per block. Okay, now again, the value that we're looking for is that it's going to continue. Okay, the rate doesn't change with the size of the block. That's really what we're looking at. Okay, that's the key here. So let's look at some of these other questions and answers. and I'm going to hide all this other